Hi, this is your review on 4.3 to 4.4 for calculus. So the first one says answer the following questions about the function whose derivative is this. What are the critical points, and then about increasing and decreasing, and local max and min. So what we start with on this one is to set this equal to 0. So 2x equals 0, so x is 0, and x plus 4 equals 0, so x is negative 4. So those are going to be the points that we're interested in, and let's graph it. X. Now if you just do x plus 4 here without the times sign, it probably is not going to like it, and so that's why you have to practice with your calculator as we're going. You need 2x times that, like that. So then you can see that negative 4 and 0 would be what we're interested in. So when the derivative is equal to 0, then it's a critical point. Then could be a critical point. And in this case, they are. What we're going to do is check our open intervals. So we put 0 and negative 4 here. We want to check our open intervals, and so that means we need negative 4 and 0, and we're going to want to test points that are smaller than this, like f prime of negative 5 to test this point. We want to test like f prime of negative 2, and that's for the middle, and f prime of 1 for the right. So all we're doing is we're basically plugging this in here. This would be like 2 times negative 5 times negative 5 plus 4, and so on. Now what I'm going to do, obviously to save time, is to just go to your table. So Control T, and I want to go to negative 5, and I see my answer is 10, and I go to negative 2, and I see my answer is negative 8, and I go to 1, and my answer is 10. So I would recommend using your table. I might need to zoom in a bit. There we go. Okay, so again on that, use the table, and you'd get positive, negative, positive. So what that means is from negative infinity to negative 4, it's increasing. Negative infinity to negative 4, it's increasing. Also from 0 to infinity, it's increasing. And then it's decreasing between it, which is at negative 4, 0. So you can get that by testing the points, which is our usual method. You can also see that on the left side, it's going down. And your minimum which we're going to need in a moment, is -2, -8. So okay, this is right. Your maximum is going to be at -4, because that's where it changes from a positive to negative. And your minimum is going to be at 0, since you're going negative to positive. So don't use the minimum of the derivative. Don't use the graph of the derivative for the minimum. Don't use your graph of the derivative for the minimum. You just want to look where it goes from positive to negative, and that was at -4, and from negative to positive, which is at 0. Now, you may wonder why you can't use the graph. Well, that's because you would need to graph f of x, not f of f prime. Would need to graph f, not f prime, to get it through the calculator. That's similar to what we said, when we originally did this. If you graph f of x, then you can visually see where it's increasing and decreasing. But if you're given f prime, we have to substitute numbers. And again, you got to look at your locals based on where it changes signs. So it's like the homework. Okay, so there's number 1. Number 2, we have 2 minus 72 over x squared with x not 0. And we want to know the critical points. So for this one, you basically want to get a common denominator. And that's going to be x squared. So in order to have a common denominator of x squared, then this has to be 2x squared. So we have 2x squared minus 72. Then what you're going to do is factor out your 2. And so that gives you x squared minus 36 over x squared. And what we're doing is we're setting this equal to 0. So when you multiply by x squared, it goes away, and dividing by 2 goes away. So you're left with x squared minus 36 equals 0, which then helps you to figure out. You use positive and negative 6. You move it over and take your square root, and you have 2 answers, and it's positive and negative 6. So those are your critical points. So negative 6 and 6. Okay, now you want to know where it's increasing and decreasing. And so basically, we're going to do our little chart, have negative 6, have 0, have 6, and test points. So f of negative 7, f of negative 3, f of 3, and f of 7. So again, I'm going to use the table to be a little faster. What I do is go to your new document, add graph, and 2 minus 72 over x squared, and go to your table, and at -7 it's positive, so I put a plus up here. At -3 it's negative. It's really -6, and this was positive 0.3 or 5.3. F of 3 is -6, which is minus, and then f of 7 is positive, because that's again positive 0.53. So it is symmetric both directions. So you can see that here with your symmetry across the y-axis. So it's a plus, minus, minus, plus. So what that means is it's going to increase from -infinity to -6. And it's also going to increase from 6 to infinity. And it's going to decrease in between -6, 0, and 0, 6. Okay, now I want to address something. The reason why you need it separate is due to the vertical asymptote at x equals 0. So basically, because of this vertical asymptote, you can't just say it's decreasing from -6 to 6. So that's why that would not work in this case. So you do need it separate like this. Okay, so our next part is where's the max? So you want to know where it goes positive to negative for the max. And negative to positive for the minimum. So going positive to negative, that happens at -6. And negative to positive right there at 6. Okay, so there's number 2. On the next one, you have f of x equal x to the 1/5, and then it's x plus 18. Okay, so this one is like 4, 3, 37. Okay, so what we first want to do is to distribute. And think of x is the same thing as x to the 5/5. And so when we distribute this, 5/5 plus 1/5 is 6/5. And then this part would be plus 18 x to the 1/5. Okay, so that's your original f function. You remember, sometimes you got to be careful, and they tell you the derivative. In this one, they gave you the original. So now we need to do f prime which would be 6/5 x to the 1/5, because we have to lower by a power. And then we'd have 18/5 x to the negative 4/5, because again we're lowering by a whole number. So now that we have our derivative, we can get our points. You can get your points from graphing the derivative. To find your critical points. So we go 6/5 x to the 1/5 plus 18/5 x to the negative 4/5. So there's your graph. And look at your table. Our y value is 0 at -3. And so that means that -3 is going to be the critical point. So it wants to know where it's increasing, and you have to relate that to the -3. Well, on the left side it's increasing -3 to infinity. And it's decreasing from -infinity to -3. So in order to find that, you can't just use this graph. We should have looked at the original graph. The original graph is x to the 1/5 times x plus 18. Okay, and so the original graph is what I have as red. This one is the one that I have as blue. So you see it's decreasing, and then all of a sudden it's increasing the rest of the way. It might be a little more clear if I disable the blue graph, so I'm just going to do a little check mark there. So there's what you got. If we do minimum, you can see the minimum is -3, comma -18.7 approximately from the red graph, which is the original. So again, to find your critical points, you either graph your original or set your derivative equal to 0. Okay, so that helps you with this part. Now for your minimum, we know that it happens at -3. This one the graph continued forever, and so there's no maximum. So for this whole block, you just pick D, which is no maximum. But for this one, there is a minimum. So the minimum is at x equal -3. Well, it wants you to use exact answers using radicals, so don't round. And so we need to figure out approximately -18.7. Well, the easiest way to do that is just use your function and plug it in. So you're basically doing -3 to the 1/5 times -3 plus 18. So the -3 plus 18 is 15. We bring our negative sign to the front because it's an odd root. So we have -15, and then it's the cube root, the fifth root of 3. So let's compare that. If you do -15 into the x and you're doing a fifth root of 3, again, that's your approximate -18.7. So that's how that works. So that's our only minimum, our only local minimum. So f of -3 equal -15 fifth root of 3. And in this case, that's also the absolute, not just the local. Also absolute min at the exact same thing. And so when it says of, that means it's a y value. So there's no absolute maximum, but there is one of -15 fifth root of 3 at x equal -3. So those two previous answers relate to each other. So that's 4,337. Okay, on this next one, it says find your local extreme values, and you have 4x plus 3x squared. But now pay attention, you have an interval here, which is like -∞, 1 bracket. So this is where you're going to have to watch out for your right endpoint. So your original is given, your derivative would be 4 plus 6x, because you just do your derivative like we've done before. And set that equal to 0, so if 6x equal -4, then x is -2/3. So that's going to be your critical point. So we're going to need -2/3. Also remember I said over here we're using 1. That's our endpoint. And then we're going to need to test on this side also. So looks like it'd be good if we do f prime of -1 and just f prime of 0. Okay, so let's get our graph. our original is 4x plus 3x squared, and our derivative is 4 plus 6x. Okay, so if we go to f of negative 1, f prime is my other one, which is negative 2, and so that's negative. And then when I go to 0, it's 4, and so that's positive. So again, you just got to pay attention to your signs as far as what's happening. You're going to have a minimum. Let's get rid of our table. You're going to have a minimum right there. On the blue graph between here and here, and it says negative 2/3, negative 4/3 basically. So do your min of your original. That gives you negative 2/3 and negative 4/3. So that's going to be C, negative 2/3 and equal negative 4/3. You just have to recognize that the negative 0.666 is 2/3, and then this 1.33 is 4/3, and then get your signs right. Okay, now let's find out what happens at 1, because that's really the last spot we really care about. So when we go to 1, f of 1 equals 7 on the original, and that's what we need. So the right side is up, and so that's a maximum. And so you're going to have a maximum at 1,7. So that's C. And this has no inflection points. What we need to do now is say what the minimum is. So the minimum was our negative 2/3, negative 4/3. So it does have an absolute minimum. Looks like there's just one, so you have to choose A. And so it's of negative 4/3 at x equal negative 2/3. So again, this and the original relate to each other. It's just this is the y value, this is the x value. And then you just pick the correct graph. And so that'd be the C graph. So you can do it like that, or you can select C. Kind of split the page right there. Okay, that's 29 minutes already. Let me go ahead and stop this video, and then I'll start another one.